Hi, in this video, I will be doing an analysis of the GeneX using APE, Cluster, and NEBcutter. Okay, let's get started. The first thing that you're going to want to do is download the folder that contains the sequences for the GeneX and its mutants. That can be found on Moodle. As you can see, I've already downloaded the folder that contains GeneX, the wild type GeneX, and its mutants. And so now I'm just going to go ahead and get started using APE, and I'm going to move from APE to the cluster to the NEBcutter in that order. So what I'm going to do, first I'm going to align the wild type with one of the mutant sequences for the GeneX. So I'm just going to go to Tools. Well, actually, I'm going to just select from, and since this particular sequence is not that large, I'm not going to select from a large range like I have in previous videos. So I'm just going to do from like 687 to 9. Now let's do 1008. 1008. We're going to do 1008. So I'm just going to highlight that particular area from this sequence. And I'm going to align this sequence with my mutant 1 GeneX. Now I'm just doing mutant 1, but you can do any one of them. You can align the wild type GeneX with any one of the mutants that's found in that particular folder, but I just chose to do 1. So I'm just gonna align it. Actually, I want my wild type to be at the bottom and my mutant to be at the top. So that's just gonna change that and press OK. And it gives me the particular area where the mutation is found, and it looks to be like the mutation is found. So you can count this looking at the little star that's above a particular new base pair. So it counts 10, 20, 30, 40, 50, 60. It looks to be at 70. So at base pair 70 is where my point mutation occurs when I align the wild type GeneX with the mutant 1 of GeneX. So now I'm just going to move on to the next step. And what I'm going to do for both of my wild type and my mutant of GeneX, I'm going to go ahead and translate them so I can use the cluster software to find out if this particular point mutation led to a change in my genetic, in the amino acid sequence that was produced, the amino acid that was produced in that particular sequence, that particular area. So let me just go ahead and translate this. And I want to use a 1-letter code. Okay, I'm not exactly sure why that happened, but we're going to go and do it over. So I'm just going to, I'm not going to copy the highlighted area. I'm just gonna let it do the whole thing since this particular sequence is so tiny. Okay, maybe that's okay that those little asterisks are popping up. I know that's not normal in some sequences, but it may be normal for this one. So I'm just gonna go ahead and see what happens. And that was the wild type. So now I'm just gonna go ahead and do the mutant. And we're gonna go translate. Keep it at 75. Okay, perfect. We're perfect now. So now we're ready to move on to the next step, which includes going to the cluster software to align these two sequences to see what amino acid, if any amino acid, had a change based on that particular nucleotide being changed by a point mutation. So I'm just going to press launch the cluster omega, and this will take you to a page that says multiple sequence alignment. And so what I'm going to do, I'm going to start with my mutant, and I'm going to use the greater than symbol and then just put the name of my particular sequence. And so gene X, I'm just going to put mutant 1. And I'm going to go and find the translation to this, and it's right here. And I'm just going to copy that. Copy the whole thing. Place it directly under the title that I provided. And I'm going to do the same thing for the wild type. So I'm going to use the greater than, and I'm just going to put WT to let me know that's the wild type and GeneX, and go and do and copy and paste its code right here. Okay. Just trying to get it to copy and paste. Okay, copy. I'm trying to get this everything in there. Okay, copy. Press copy. We're gonna paste it. And we're going to press submit. And my sequences are running. Okay, I'm not exactly sure why it's showing up like this. So this lets me know that something was done wrong with my particular sequence. So I'm just going to go ahead and try to figure out what exactly, if anything, went wrong with it. So I'm just going to try again with my translation, because sometimes you will have an error in that, and the cluster won't recognize that particular sequence. So I'm going to keep the copy highlight, and I'm just going to keep everything the same as I done the very first time, and press OK and see what I get. Okay, so the wild type looks okay, but it seems to be a problem when I try to do the mutant. And I'm just going to go ahead and clear some of these out. Okay, so we're left with the so we have the wild type, and we also have the mutant of this particular sequences that we're comparing. So I think this looks right now for both the wild type and mutant. So I'm just gonna run it again so we won't get any errors like we did the first time. So I'm just gonna go back to the cluster omega multiple sequence. I'm gonna do the same thing. I'm gonna align my GeneX. GeneX1. And I'm gonna go ahead and copy that for the mutant. Copy, paste. Okay, and then I'm just going to name my wild type wild WT gene X. I'm going to space it out slightly, just slightly, and go and find its sequence and copy it into here. And this should work this time around. And I'm just checking it to make sure that I copied the right gene for both. Since they look so similar. Okay, so I'm just gonna press submit. And I'm waiting. Okay, now we're right. This is exactly how it should look. Please excuse the error that I made the very first time. I'm sorry about that, but this is how it should look. And I'm able to go directly to where my mutation occurred, and I can see that the amino acid for that was coded within that sequence was changed. And if I look on my chart right here that I have for amino acids, and it went from a S, which is serine, to T, which is T can be one of two things. It can be thyrine or tyrosine. So it was obviously a change occurred with the amino acid sequence that was coded using that particular nucleotide sequence. So we know that that point mutation did have an effect. So now it's time to move on to the NEBcutter, and the NEBcutter is going to allow us to see which restriction enzyme will cut that particular point mutation out of that sequence, so our protein sequence isn't affected by that small little point mutation, which can have very damaging consequences depending on its function in an organism or whatnot. So I'm just gonna go to the NEBcutter, and what I'm gonna do, I'm gonna go to our reading frame, and I'm just gonna pick maybe 25, 30 nucleotides from our wild type, and I'm gonna do the same thing from our mutant. So I'm just gonna pick a few that fall within the range of where that mutation was found, and it can be a little bit less. That's okay as well. So I'm just gonna copy and paste it in here. Okay, keep it linear. You can name it if you want to, but so I guess I could just go ahead and put gene at X1, and I'm just gonna press submit. Okay, so it tells me the particular enzymes that will be good to possibly cut out that point mutation. So what I'm just gonna copy and paste my picture. I'm just gonna copy this picture and just gonna place it into a Google Doc so that I can compare the two and make a decision on which one I would feel would be best to use to cut that particular point mutation out of our sequence. So we're just gonna copy and paste our picture, allow access, and hopefully our picture loads up. Okay, and this is the picture for the gene X1. I'm going to do the same thing for gene X for just the wild type gene X. So I'm just going to take a few and I'm going to copy, go back to the NEBcutter, and you can just go press back, clear out that initial sequence and paste in your new sequence. And I'm just going to change the name to GeneXWT for wild type and press submit. Okay, gives me another map with the options of nucleotide restriction enzymes that can be used to cut away at certain nucleotides, in particular where that point mutation occurs. So I'm just going to copy that picture, make sure my picture copy, and go back to my little Google Doc where I'm working in so I can just make my comparisons. I'm just going to call this gene WT for wild type gene X1. Okay, so now I'm going to just analyze the picture, and I'm also going to be going back to my reading frame as well. So looking at the reading frame, I'm just going to let's see what basis landed. So the sequence, it was CAC for our mutant, and for the wild type, it was CTC. So we're going to look for that on our chart. And we're just going to go back here. Let's see. So I'm looking for that particular sequence, and I said it was CA. We're looking for CAC and CTC on here. So I found CAC CTC, and now I'm looking for CTA, and that's probably going to be down here. Yeah, perfect. So we got CAC right up here and CTC up here, and we're looking for the the restriction enzyme that would be best to snip away that point mutation without snipping away certain nucleotides that we want to keep. So I feel that the best restriction enzyme that should be used to snip away the error that is found in the mutant gene X1 compared to the wild type gene X1, I feel that MSPJ1 would be a good restriction enzyme to repair that particular sequence, since it won't be cutting away at the sequence that we want, the nucleotides that we want to keep. So I'm just going to do a quick Google search on this particular enzyme, just the MSPJ1 enzyme. Oh man, I spelled enzyme wrong. Enzyme. I'm gonna go back and double check how you spell it. MSPJ. Okay, I'm just gonna press enter because I want to see in what particular sequence types that particular enzyme will work. Let's see. And we want to cut out a A. So yes, that would be a good enzyme to use to cut. Hold on. Whoa. Sorry about that. So as I was saying, that would be the MSPJI enzyme would be a great enzyme to cut that particular point mutation or remove that point mutation away from that sequence in order to avoid having a change in amino acids, the amino acid sequence based upon that point mutation. And as you can see, you can use various software to tell you different things that you would want to know for a sequence. So all you have to do is have a wild type sequence and a mutant sequence, and you can easily figure out which, if a restriction enzyme, you want to possibly remove that point mutation, where the point mutation actually occurs. So this is these various software programs that allow molecular biologists to figure these things out are very useful, because in order we wouldn't be able to figure out things of the sort, and that can be very bad on a molecular level if we were talking about someone who had maybe had cancer or some particular disorder that was related to genetics, and we want to be able to figure out exactly at what point and what is happening to cause those mutations, and we can use software just like that. I hope you learned a lot, and thank you for tuning in.